So let's talk about quantum computers. It's one of those topics that's absolutely world-changing. But let's be honest, it can be seriously confusing. What if I told you they're not just faster computers, but something else, something completely different? Well, let's dive in and figure this out together. If you follow tech news at all, you've definitely seen the headlines. You hear all these buzzwords, quantum supremacy, qubits. But a lot of this talk is, well, it's not quite the full picture. A lot of it's just plain wrong. They are not just souped-up supercomputers. So, what's the real story here? What can these machines actually do? And more importantly, why should we care? That's what we're here to do. We're going to cut through the hype and figure out what a quantum computer really is. To get our heads around this, there's a fantastic analogy from a quantum physicist that I really love. Instead of thinking about computing as just a race to be the fastest, I want you to picture it as an exploration, like we're trying to explore a vast, uncharted map. Way back in the beginning, we were basically walking, we had pencil and paper, right? We could solve some basic geometry, but it was super slow, and huge parts of that mathematical map were completely out of reach. Then we got early computers, let's call those our horses, and they let us travel farther, faster. And today we have classical computers. These are like our cars, zipping along a whole network of highways, solving incredibly complex problems we never could have dreamed of before. But here is the absolute key. This is the most important part. A quantum computer isn't just a faster car, like some kind of Formula One racer. No, it's a completely different kind of vehicle. It's a boat. And that just perfectly sums up the whole idea, doesn't it? A boat isn't better than a car. You wouldn't take a boat to the grocery store. It's just built for a totally different kind of terrain, water. And that's what quantum computers are. There are boats designed to navigate these new mathematical oceans, to solve problems that our cars, our regular computers, they just can't touch. They can't even get to the water's edge. Okay, so if a quantum computer is a boat, what kind of engine is powering this thing? Well, the difference really comes down to the most fundamental level, how it actually processes information. So your phone, your laptop, everything you use every day runs on bits. And a bit is pretty simple. It's like a light switch. It can only be on or off, a 1 or a 0. That's it. It's binary. But quantum computers, they use qubits. And a qubit, it's more like a wave in a pond. It isn't just a 1 or a 0. It exists as a probability of being both at the exact same time. It's this weird mixed state. So how does that even work for a calculation? Well, when you get a bunch of qubits together, their probabilities, their waves, start to interact and interfere with each other, kind of like ripples in a pond. Some waves add up and get stronger, while others cancel each other out completely. The quantum computer is basically designed to watch this whole pond of interacting waves and find the most probable, the most likely answer that emerges from the pattern. And this brings us to a huge misconception that you hear all the time. People say quantum computers are so powerful because they try every single possible answer at once. That's not quite right. It's actually way cleverer than that. Instead of just brute forcing the problem, they use this beautiful wave interference to quickly narrow down and find the right solution. It makes them unbelievably efficient for very specific kinds of problems. Okay, so we've got our boat. We kind of understand its weird and wonderful engine. Now for the big question. What's actually in the water? What new lands can we explore with this thing? Right now, as we speak, there are two massive areas where quantum computers are pretty much guaranteed to cause a revolution. The first one is incredibly creative and full of promise. And the second one, well, it's incredibly disruptive. So let's start with simulating nature. As IBM researcher Olivia Lanes puts it so perfectly, the universe, when you get down to the molecular level, it doesn't run on simple ones and zeros. It runs on the strange, probabilistic rules of quantum physics. Our normal computers, our cars, they really struggle to model that watery, quantum world accurately. But a quantum computer, it speaks the same language as nature. I mean, just imagine for a second, if we could perfectly predict how molecules will interact. We could design revolutionary new medicines from the ground up. We could create hyper-efficient batteries or even invent new materials that we can't even conceive of right now. That's the amazing promise of exploring this part of the quantum ocean. All right, now for that second, more disruptive application. Why are governments all over the world basically in a race to build these things? And why does the word encryption always seem to come up in the same breath? Billions of years. Let that sink in. That's roughly how long it would take one of today's best supercomputers to break a common form of internet encryption. Our entire online security, all our data, relies on the fact that this calculation is just ridiculously hard for a normal computer to do. And this is the estimated time for a powerful quantum computer to do the exact same thing. Not billions of years, we're talking hours, maybe days. This is exactly why it is such a monumental deal. The mathematical lock that protects almost everything today is just no match for the key that's being built. So that all sounds pretty scary, right? How close are we to this future? When are these quantum boats actually going to be ready to, break all of our encryption? Well, let's get some perspective. Right now, the record for a quantum computer is 433 qubits. But to crack modern encryption, scientists estimate we're going to need a stable machine with 1 million or more qubits. So, yeah, there's a pretty significant gap. We're definitely not there yet. But, and this is a huge but, the thing to remember is that progress is happening at a mind-blowing speed. Researchers are solving problems today that just a few years ago seemed completely impossible. And that's why the race is already on to develop what's called quantum-safe encryption. Most experts expect these new, tougher algorithms to become standard within the next 5 years. We're essentially trying to build new locks before the master key is fully cut. So if we go back to our analogy one last time, we've really only just begun to skim the surface here. Simulating nature, breaking encryption, these are just the first 2 continents we've spotted from our boats. As this technology gets better and better, we're going to discover new applications, solve problems we don't even know we have yet. It really is a bottomless ocean of possibilities. And maybe the most beautiful, the most profound part of this whole thing is this final thought. We're not just building a new kind of computer here. We are building a tool that operates in the same bizarre, wonderful way that the universe itself operates. We're building a machine to help us understand the fundamental nature of our own reality. The real question is, what are we going to find when we can finally explore it?